So dear 9th class students, we have started polynomials. In these polynomials, I am going to discuss now division algorithm of polynomials. Heading is division algorithm of polynomials. Did you understand the heading? Right. See, what is division algorithm of polynomials? Here I am writing on the board. Clearly you see, if p of x is a polynomial, if p of x is a polynomial, whose degree means already we have discussed the highest power of the variable appearing among the all terms in the polynomial, highest power of the variable. So if p of x is a polynomial whose degree is greater than or equal to, the degree of p of x is greater than or equal to the degree of g of x, another polynomial, degree of polynomial g of x are you following? Now here there are polynomials p of x and g of x, where the degree of polynomial p of x is more than degree of the polynomial g of x, or at least both degrees are equal. Then there exist polynomials, q of x and r of x. There exist polynomials q of x and r of x are such that there exist polynomials q of x and r of x such that p of x is equal, see this is most important, g of x into q of x into q of x plus r of x. P of x is equal to g of x into q of x plus r of x, where degree of r of x is strictly less than degree of q of x. Understood? So this is division algorithm of polynomials. Once I repeat, you see, if there is a polynomial p of x whose degree is more than or equal to degree of the polynomial g of x, then there exist polynomials q of x and r of x such that p of x is equal g of x into q of x plus r of x, where degree of r of x is lesser than degree of here it is degree of g of x. Degree of r of x is lesser than degree of g of x here. Understood? So this can be clearly explained as, you see here, here there is a polynomial p of x. The division algorithm of polynomial I am explaining here. Here there is a polynomial p of x. Here it is dividend. And this is the divisor. The another polynomial g of x is the divisor. Now we have divided p of x with g of x. Then you got the quotient q of x. And that in the division process, you got the remainder r of x. And this degree of r of x, this degree of r of x should be strictly less than degree of g of x. That is the most important point in this definition you have to understand. The degree of r of x, the degree of remainder should be strictly less than degree of the divisor. Are you following? So this is division algorithm of polynomial. Once again I am saying p of x is equal to g of x into q of x plus r of x. This is the division algorithm of polynomials. Now let us take one example now. Now I am taking an example. Divide two x cube minus 3x square plus 4x minus 5 by x plus 2 and find quotient remainder. And also verify the division algorithm of polynomials. Verify division algorithm of polynomials. That is the question. So now let us take first part of the question, dividing this polynomial by x plus 2. And getting quotient and remainder. So, see here now. You know the division process. So, go to rough work. 2x cube. Go to rough work. This has to be in rough. 2x cube by x you have to take. 2x cube divided by x, which gives you 2x square. Right? So, here you have to take 2x square. Are you following? Now, plus into plus, plus x into 2x square, 2x cube, plus into plus, plus 2 into 2x square, which is 4x square. Are you following? Now, we have to change the symbols because here we are performing subtraction. So, here minus, here minus. Right? Then this plus 2x cube minus 2x cube get cancelled. So, minus 3x square minus 4x square, you have to take here minus 7x square. As minus 3x square minus 4x square is minus 7x square, you please drop 4x here. And again go to rough work and you take minus 7x square divided by x, which you get minus 7x. So, Here you take minus 7x. Now you multiply plus into minus minus. X into 7x, 7x square. Plus into minus minus. 2 into 7x, 14x. Now change the symbols. Here you get plus. Here you get plus. Now here this and this get cancelled. 14x plus 4x, 18x. Are you following? Now you drop minus pi. Right? Now multiply. Here you go to rough work first. So 18x divided by x, which is 18. So plus 18. Now you multiply. Plus into plus plus, x into 18, 18x. Plus into plus plus, 2 into 18, 36. Now the symbols, you have to change this minus. This is minus. Then this and this get cancelled. Minus 36 minus 5, which you got minus 41. Minus 36 minus 5 is minus 41. Therefore, what would be the quotient? Quotient would be 2x square minus 7x plus 18. Remainder would be minus 41. So now let us take all this. Now whatever we took, let us take now P of, because we have to verify division algorithm. So verifying division algorithm. For verifying division algorithm, take all P of x, etc. So here P of x is 2x cube minus 3x square plus 4x minus pi. What is g of x? X plus 2. And what is q of x? Q of x is this, 2x square minus 7x plus 18. Now, what is r of x? Minus 41. Now, we are going to verify division algorithm. So in division algorithm of polynomials, what is LHS? It is P of x, which is 2x cube minus 3x square plus 4x minus 5. Now what is RHS in division algorithm of polynomials? What is RHS? G of x into Q of x, right, plus R of x. This is RHS of division algorithm of polynomials. Now you substitute. What is g of x? It is x plus 2. This has to be kept in brackets without fail. Into what is q of x? You got 2x cube minus 3x square plus 4x minus 5 plus r of x. What did you get? Minus 41, right? Now, just multiplying now. So now, here I am cleaning this, please, with your permission. Now you multiply now. So you multiplying using distributive law. X into this whole thing, 2x cube minus 3x square plus 4x minus 5. Are you following? X into this whole thing. Now plus 2 into this whole thing. Plus 2 into this whole thing. 2x cube minus 3x square plus 4x minus 5 plus into minus minus 41. Okay? So now this is equal to, now you multiply, so 2 into x power 4 minus 3 into x cube plus 4 into x square minus 5x plus 2 to the 4x cube minus 6x square plus 8x minus 2 5 are 10. So 4x cube minus 6x square plus 8x minus 10 minus 41. Did you understand? So I am multiplying 2x cube 2 into x cube into x, 2x power 4 minus 3x cube plus 4x square minus 5x plus 4x cube minus 6x square plus 8x minus 10 minus 41. Now 2x power 4. Now if you group the x cube terms, so this is 4x cube minus 3x cube, which is plus x cube. Now if you group the x square terms, 4x square minus 6x square, which is minus 2x square. And if you group the x terms, that is 8x plus 8x, this is minus 5x. 8x minus 5x plus 3x. So if you group the constants, right, minus 10, minus 41. Any more constants? No. So minus 51. So 2x power 4 plus x cube minus 2x square plus 3x minus 51. Understood? So this is equal to P of x. Right? So we have proved that LHS is equal to RHS. Hence we have proved the division algorithm of polynomials. Understood? So our next point of discussion is most important theorem. It is remainder theorem. So remainder theorem. So what is remainder theorem? I will write here. You see, if P of x is a polynomial of degree n, which is greater than or equal to 1, So if p of x is a polynomial of degree n which is greater than or equal to 1 and a is any real number and a is any real number, then when p of x is divided by the linear polynomial x minus a, when the p of x is divided by the linear polynomial x minus a, then the remainder is p of a. So this is our remainder theorem. Please see this statement carefully. If p of x is a polynomial of degree n which is more than or equal to 1 and a is any real number, then when p of x is divided by x minus a, then the remainder is p of a. Okay? Here instead of then you put and. So this is the statement. So now, did you understand? See, here now I will explain. Here what is happening is, there is a polynomial p of x whose degree is n and that n is equal to 1 or more than 1. Now, for any real number a, you are dividing p of x with x minus a. Are you following? Then the remainder theorem says, in this division you get the remainder p of a. A being constant, p of a is also constant. So now we'll prove this, not just we write this, we'll prove this. In the course of proof, we explain the division process. So, if we are, see, let q of x be the quotient and r be the remainder, when p of x is divided by x minus a. So in the division process, what we are considering, q of x be the quotient and r be the remainder when p of x is divided by x minus a. So like this you see here. So here p of x, you are dividing this with x minus a, you got some quotient q of x and the remainder r constant. Here the remainder is constant. We can support our argument. See here, always the degree of the remainder is strictly less than the degree of divisor. The degree of divisor is 1, so the degree of remainder is less than 1. So the only possibility is it is 0. Less than 1 means it is 0. So the degree of remainder is 0. Remainder 0 means it is a constant. So here our remainder is constant. So this is how the division process has gone. So therefore, by using division algorithm of polynomials, I am using abbreviation, then what do you get? P of x is equal x minus a into q of x plus r. So by division algorithm we get P of x is equal x minus a into q of x plus r. Now the division process is finished. Now go for verifying P of a value. So now put x is equal to a in this equation 1. Put x is equal to a in 1. Then what do you get? P of a. So in the place of x you have to put a, which is equal to a minus a into q of a plus r. So P of a is equal 0 into something 0. So it is 0 plus r. So P of a is equal to r. Therefore the remainder is equal to P of a. This is how we have proved the remainder theorem. So the use of remainder theorem is, if you divide a polynomial with a linear polynomial, then whatever the remainder you get in the actual division process, the same remainder you can get without actual dividing, in fact finding P of a. This is the central idea of remainder theorem. So now we'll do one problem and we'll verify the remainder theorem. Okay? So let us take an example. Divide x cube plus x square minus x plus 2 by x plus 1. Okay, and find the quotient and remainder by actual division. Only one problem, only for our satisfaction purpose. Though we know we have proved the theorem, just we are checking with one problem. There is no any wrong if we do so, but in future only to find remainder when you are dividing a polynomial with a linear polynomial, only to find remainder, it is not necessary to perform the actual division. Just go for calculation of P of a, that would be the remainder. So divide x cube plus x square minus x plus 2 by x plus 1 and find quotient and remainder. And hence verify the remainder theorem. Verify the remainder theorem. This is the question. So now we have to actually perform the division. So to solve this question, so this has to be divided with x plus 1. So divide this with x plus 1. So go to rough work, x cube by x, which is x square. So here you put x square, right? So x into x square, x cube plus x square. Now in subtraction the symbols gets changed. So this is minus, plus x cube minus x cube get cancelled. Plus x square minus x square is also going to be cancelled. Now what is left over? minus x plus 2. Okay, now go to the rough work. Minus x by x. Are you following? Minus x by x, which is minus 1. So here you put minus 1, then it is minus x plus into minus 1. Right? So now in subtraction the symbols will change. Now this minus x plus x get cancelled, plus 2 plus 1 plus 3. So if you perform the actual division, you got the remainder 3. So now take P of x is equal, now verification of remainder theorem. Verification of remainder theorem, take P of x is equal x cube plus x square minus x plus 2. Now go to rough work. You are dividing with x plus 1 equated to 0 and get the value of x, which is minus 1. Here now that minus 1 is a. P of a means P of minus 1. So find out P of minus 1, which is equal minus 1 the whole cube plus minus 1 the whole square minus of minus 1 plus 2. This is minus 1 and this is plus 1 and this is plus 1, this is plus 2. Minus 1 plus 1 get cancelled, 1 plus 2 3. So you got, you see, the same remainder you got. So hence remainder theorem is verified. Understood? So dear students, now we have discussed remainder theorem. Now we can take some note points. As a note number 1, when f of x is divided by f of x is divided by ax plus b, if f of x is divided by ax plus b, the remainder is f of minus b by a. Little extension. See, we have discussed remainder theorem. If f of x is divided by x minus a, remainder is f of a. So now we are expanding to the linear polynomial ax plus b. So if f of x is divided by ax plus b, remainder is f of minus b by a. If it is divided by ax minus b, the remainder is f of b by a. I am not writing the complete statements. And if that f of x is divided by something like x plus a, the remainder is f of minus a. So these all are note points. You can take this. So if the polynomial f of x is divided by ax plus b, the remainder is f of minus b by a. If it is divided by ax minus b, the remainder is f of b by a. If the polynomial is divided by x plus a, the remainder is f of minus a. Finally, the simple point is, okay, whatever the divisor he gave, you go to rough work, you equate the divisor. The divisor is the linear polynomial, I am saying. Divisor here, as long as the remainder theorem is concerned, the divisor should be only linear polynomial. If the divisor is some quadratic or cubic polynomial, that remainder theorem is not applicable there. So here please do understand one point. In remainder theorem, divisor is a linear polynomial. So whenever you are applying remainder theorem to solve a problem, go to rough work, take the divisor, equate it to 0, get the value of x. At that value of x, find the functional value. That would be the remainder. It is very simple to understand. So now coming to next topic, factor theorem. This both remainder theorem, factor theorem plays major role in your polynomial chapter. So factor theorem, the statement is if f of x is a polynomial, if f of x is a polynomial of degree n, greater than or equal to 1, if f of x is a polynomial of degree n greater than or equal to 1, and a is any real number, then number 1, f of a is equal to 0. If f of a is equal to 0, then x minus a is a factor of f of x, is a factor of f of x. Second is its converse. Both we are proving. P implies Q and Q implies P also we are proving. Second is, if x minus a is a factor of f of x, then f of a is equal to 0. So this statement is most important, factor theorem. Once again here I will read, you please see carefully. If f of x is a polynomial of degree n more than or equal to 1 and a is any real number, then if f of a is equal to 0, then x minus a is a factor of f of x. If x minus a is a factor of f of x, then f of a is equal to 0. So both ways we are proving. Okay. Now proof of part 1. With your permission, I am cleaning the board. So proof of part 1. So f of x, by using division algorithm of polynomials, by using division algorithm of polynomials and remainder theorem, both in combination I am using. By using division algorithm of polynomials and remainder theorem, you get f of x is equal to, are you following? X minus a into q of x. Q of x is quotient plus f of a is remainder by remainder theorem. But we are given that f of a is equal to 0. Therefore f of x is equal x minus a into q of x plus 0, which is f of x is equal x minus a into q of x. That means f of x is having a factor x minus a. What does it mean? It means that it is the meaning, x minus is a factor, it is a multiple of q of x. F of x is equal x minus a into q of x. So x minus a is a factor of f of x. Therefore x minus a is a factor of, understood? Factor of f of x. It is very simple. See, when f of x is f of x is some x minus a times of q of x, it is very clear that x minus a is a factor of f of x, right? So now we are proving that part 2. In part 2, it is given that x minus a is a factor of f of x. Proof of part 2. So, we have given that x minus a is a factor of f of x. So, when x minus a is a factor of f of x, obviously f of x would be x minus a into some polynomial q of x, because it is a factor. Now, you put x is equal to a, then f of a would be a minus a into q of a. So, f of a is equal to 0 into something 0. So, both ways we have proved. So, with this we have proved factor theorem. So, what is the use of factor theorem? It is very simple. In any situation, if f of a, you have seen it is 0, you can conclude x minus a is a factor of f of x. Or if it is given in the question that something like x minus a is a factor of f of x, you can take f of a is equal to 0. See, for example, a small example I am taking to make you very clear with the concept of factor theorem. Verify x minus 2 is a factor of f of x is equal x cube minus 2x square plus 3x minus 5. So, find out f of 2. This is 2 cube minus 2 into 2 square plus 3 into 2 minus 5, which is equal to 8 minus 2 square is 4, 4 2s are 8 plus 6 minus 5. 8 minus 8 is 0, 6 minus 5 is 1. So, f of 2 is equal to 1. Therefore, what does it mean? F of 2 is not equal to 0. It is 1 means it is not equal to 0. Therefore, x minus 2 is not a factor of f of x. Understood? Not a factor of f of x. Right? Now, let us do one more problem. Verify whether x minus 1 is a factor of x cube minus 4x square plus 5x minus 2. Verify whether x minus 1 is a factor of this polynomial f of x. So, now you put x is equal to 1, f of 1, 1 cube minus 4 into 1 square plus 5 into 1 minus 2. So, 1 minus 4 plus 5 minus 2. 1 plus 5, 6 minus 4 minus 2, 6. 6 minus 6, 0. F of 1 is 0. Therefore, x minus 1 is a factor of f of x. Understood?